Let's start with question number 9. Count the number of terms. Ready, set, go. What type of polynomial is this called? Okay. This is a binomial. It's not a difference of squares because if I can't take the square root of both of these. So the very first thing before I even count the number of terms is I need to look at your factoring flow chart. Before we even count the number of terms, we're going to have to. We need to find the GCF first. Now, I normally don't do this for problems, but I just want to show you what it means to find the greatest common factor. 8x squared can be written as 4 times 2 times x times x. Negative 4x can be written as negative 1 times 4 times x. Class, what do they have in common? And what else? I'm only putting one x out here. Okay? Class, what is not circled? 2x minus 1. In this problem, we just factored. The answer is 4x times quantity, 2x minus 1. You can check your factoring by multiplying. Let's do that. 4x times 2x is 8x squared, and 4x times negative 1 is negative 4x. In this problem, you can recognize you don't have to factor anymore, and you might be asking, why do we factoring? It's because yesterday's lesson, then you can graph something like this through multiplicity. Let's try number 8. Partner B, tell partner A, what do you think the greatest common factor is? Go. Class, show me with your fingers. It is a 3. Now, watch this. A common mistake is to actually think the answer is 3x. Although there's an x here and an x here, this one does not have an x. So x is not even a common factor. So 3 is our greatest common factor. Class, what's left? X squared plus 8x minus 9. Pay attention. Now, inside here, I have a count the number of terms. Ready, set, go. So what type of polynomial? And if it's a trinomial, then we can use the x. Let's do that. Now, notice how I highlighted in yellow inside the parentheses. Inside the parentheses, a times c is negative 9. Class, what is my b value? Okay, I want to point out why I, again, drew the inside the parentheses is because a lot of students say, well, Mr. Ng, I factor out a 3, and then they go back up here to this original polynomial. That would be incorrect. Now, the great thing about math, it's very forgiving, is you can actually go with the X box method even if you didn't know the greatest common factor. You'll get the same answer. I need two numbers when they multiply, or their product is negative 9, but you add those two numbers to find their sum to be 8. Class, what are those two numbers? Now, here's a strategy when they get larger. You write all of the factors of 9 on the side, and you write the larger number on the left side. Some of you guys already said it was 9 and 1. But now I have to think about positive negatives. Is there any going to be negative? Negative 1. 9 times negative 1 equals negative 9. 9 plus negative 1 equals positive 8. 9 and negative 1 become my binomials. Now, another common mistake is to forget about this greatest common factor. It just keeps falling down with our problem. So I have x, 9 here is positive, and I have x minus 1, and this is our answer. 3 times the quantity, x plus 9, x minus 1. Another clue of how do you know that you can use the Xbox method. Class, what is half of 2? Is 1. When it's half, then you can use your Xbox. Let's try question number 4. Partner A tell partner B the greatest common factor. Natalie, what's the greatest common factor? So we have a 5 times x to the 4th minus what, class? 2x squared plus 4. Okay, now I have this here inside the parentheses. Let's see if we can factor this one again. Now this looks kind of different. This is not even a quadratic. Well, class, what's half of 4? 2. Okay, so I have a trinomial, so I'm going to try to use the Xbox method. Inside the parentheses, you can use your finger. It's a great tool. You can cover up the GCF. Class, what's A times C? And your B value. 2 numbers that multiply to be 4 but add to be negative 2. Is there any numbers? There are no numbers. In pink, this is called a prime factor. What does that mean? It means that we cannot factor these into binomials. It means that this is actually your answer. In this problem, all you did was just pull out a greatest common factor, and that's your answer. So the very first thing you should always do in all these problems is pull out the greatest common factor.